So our problem is 494. Now we have the question: express the moment of the couple acting on the pipe assembly in Cartesian vector form. Solve the problem using equation 413 and summing the moment of each force about the point O. So first we are going to we are asked for for the solution of the problem by using a force couple. So basically directly using the distance between these two forces, relative position vector, and then in the second part we are asked for the solution of the problem directly by calculating the moment of each force separately with respect to the origin and summing them up. Okay, so this is what is asked to us. Therefore, first thing that we need to do is to write the position vectors, since the Cartesian form of the force vectors are already given to us. Coordinate system is given. X-axis is in this direction, Y is horizontal, and Z is vertical. Therefore, this is our first point, and let's say that, okay, so this is point A. And this is our point B. Okay, now we will write the position vectors of point A and point B. Certainly the point A has a position vector of minus 0.3 k vector, and point B does not have any x component. Therefore it is 0.7 minus 0.7 k vector and plus 0.6 j vector. Now let's write it like this. So RA is equal to minus 0.3 k vector and RB is equal to 0.6 j vector minus 0.7 k vector. First we will calculate the force moment of each force with respect to the origin. We will begin by the force acting at point A. Remember that it is minus F and RA is minus 0.3 k. F is equal to 6I minus 2J minus 3K. So if you make the multiplication, certainly you only have I and J components. Multiplying K with the I vector will give you positive J, and we have a negative sign here, so it is minus 1.8 J vector. Now multiplying K with J will give you negative value, and here we have another negative sign. As a result, it is minus 0.6 I vector in Newton meters. Of course, the unit is Newton meters. Now let's calculate the moment of force at point B with respect to the origin. It is the RB vector product F. So RB is 0.6 J minus 0.7 K, and the force is negative of this one. So it is minus 0.I plus 2J plus 3K. If you do the multiplication, what you are going to get is 3.2 I vector, 4.2 J vector, and 3.6 K vector in units of Newton meters. Now the net moment with respect to the origin is summation of these two moments. Then so it is 2.6 I vector. Here it is 2.4 J vector, if you sum up minus 1.8 with 4.2, it makes 2.4, and at the end it is plus 3.6 k vector. So x component, y component, and z component of the moment vector is 2.6, 2.4, and 3.6 respectively. Now let's calculate the net moment with respect to the origin by directly calculating the relative position of B with A, or well, yes, from B to A, or A to B, let's say, that's better, relative position of A with respect to B. So then what we do is we subtract RB, we subtract RA from RB, and putting a minus sign here will give us positive value. As a result, RB minus RA is 0.6 J vector minus 0.4 K vector, and in fact we will multiply it with the F, the force vector, at point B. It is minus 6I plus 2J plus 3K, and the results will be 2.6 I vector, 2.4 J vector, and 3.6 K vector, and the result is in Newton meters.